Hello, today we're going to be looking at areas and volumes of cones. A cone is a three-dimensional shape, but it is not a polyhedron because of its curved surfaces. When you take a look at a cone, it has one base, which is always a circular base. It also has a vertex point, which is where the lateral surfaces intersect, typically up at the top or the bottom of the cone. When we talk about cones, we have two different types of cones based on how they look, an oblique cone and a right cone. Like the other shapes we've discussed, a cone is oblique if its axis is not perpendicular to the base. The cone is right if the axis is perpendicular to the base. Just like in our other shapes, we're going to connect the vertex point to the center of the base in order to find our axis. So you can see in the first picture how the axis is not perpendicular and the height is drawn separately, versus our second picture here when we connect the vertex to the center of the base, our height is perpendicular. In a cone, we have our normal height perpendicular to the base, but we also have something called the slant height. The slant height is if you were to slide down the side of the cone here, and that's represented by the letter L. The slant height, your normal height, and your radius create a right triangle. So we're going to use Pythagorean theorem or special right triangles often in order to find one of those three measures. So we know that the height squared plus the radius squared is equal to the slant height squared. Be careful of which height you're using. In our area formulas, we're going to need to know the slant height, but when we get to our volume formula, we need to use the regular height. When you take a look at the formulas for the areas of a cone, we have the lateral area of a cone, pi r L, so pi times the radius times the slant height. And then our surface area formula, just like for all of our other shapes, is our lateral area plus the area of the base. So for a cone, if we calculate the lateral area, we're just calculating this curved portion. So think about an ice cream cone. If you needed to know how much waffle to create an ice cream cone, you would find the lateral area. If you were to create some sort of conical container and then put a lid on top, that's where you would need to know the surface area, covering all of the sides. Okay, let's take a look at a few examples. So question number 1, Diego has a conical lampshade with an altitude of 6 inches and a diameter of 12 inches. Find the lateral area of the lampshade. So for question number 1, we're going to use our formula, pi times the radius times the slant height. We can see that the radius of the base here is 6 inches, and our normal height, our altitude, is also 6 inches. To find the lateral area, we need to know the slant height. So if I create a right triangle from the height, radius, and slant height, I can find the lateral area either by using Pythagorean theorem, 6 squared plus 6 squared equals L squared, or since I recognize that this is an isosceles right triangle, I know it has to be a 45, 45, 90, and that the slant height, therefore, must be 6 root 2 units. If we plug in our numbers into our formula for lateral area, we have pi times the radius of 6 times the slant height, 6 root 2, and that gives us a lateral area of about 159.9 square inches. In question number 2, we're asked to find the surface area of each of the cones. So our surface area is our lateral area, pi RL, plus the base, which is a circle. So pi r squared. In the first question, we're given the radius of 10 centimeters, and we're also given the slant height I know this is the slant height because if they meant the regular height, they would either put it closer to the dotted line or draw an arrow. So for this particular question, I have everything I need to get the surface area. So I'm just going to plug and chug pi times the radius of 10 times the slant height of 17 plus pi times 10 squared. The surface area of this first cone here is about 848.2 centimeters squared. When I take a look at the second cone, we're still finding our surface area. So pi times the radius times the slant height plus pi r squared. When you take a look at this picture, we have the regular height, the letter H. We have our radius, r, but we're missing our slant height. This happens to also be an isosceles right triangle, since the height and radius are the same. So I know it says 45, 45, 90. So our slant height, following the 45, 45, 90 pattern, must be 8 root 2 units long. Now when I plug into our formula for surface area, I have pi times the radius of 8, our slant height, 8 root 2, plus pi times 8 squared. When you put this into your calculator, you should get a total surface area of about 485.4 square inches. In question number 3, the surface area of a cone is 1,020 square meters, and its radius is 14.5 meters. Find the slant height. So let's start by writing down our formula. And then we're going to plug in everything we know. So surface area, 1,020. Our radius, 14.5. We're looking for our slant height, so we'll leave that letter L. Plus pi times 14.5 squared. Okay, I'm going to clean up the equation a little bit. So 1,020 equals 14.5 pi times the slant height, plus, when I put the area of the base into my calculator, I get about 660.5. To solve for L, we're going to subtract that 660.5 from both sides. So our equation now says 359.5 equals 14.5 pi L. And when we divide both sides by 14.5 pi, we get that our slant height is 7.9, and this will be in meters. Okay, when you flip over to the back of the notes, you'll see that we're now going to find the surface area of 2 different solids. These are comprised of 2 of the shapes that we've discussed already. So if you take a look at the first picture in question number 4, we have a cone sitting on top of a cylinder, and our job is to figure out the total area that needs to be covered in this solid shape. So we're going to be using some of our lateral area and surface area formulas for cone and cylinder, but we're going to have to adjust them according to this particular solid. So when you take a look at question number 4, if I start with just the cone, and I think about what parts of the cone would need to be covered in this figure, the only portion of the cone that gets covered is this slanted portion. So that's the part that's sort of like the waffle cone for ice cream. I do not need to cover the base because that's hidden within the solid. So in order to figure out the area for the cone, I'm going to calculate lateral area. So that's pi r times our slant height. When you take a look at this picture, we have our radius of 6 inches for the cone. Our normal height is 4 inches, but we're missing our slant height. So we create our right triangle, and then we can use Pythagorean theorem to find the slant height. So 4 squared and 6 squared equals the slant height, L. That's 16 and 36, or 52, equals the slant height squared. And when we square root both sides and simplify, our slant height is 2 root 13. So for our cone, we have a lateral area of pi times the radius of 6 times our slant height, 2 root 13. And that's about 135.9. Okay, then if we take a look at the cylinder portion of this picture, for the cylinder, we need to cover the curved part of the cylinder and the bottom base of the cylinder, but we would not cover the top of the cylinder because it's hidden within the solid. So for the curved portion of the cylinder, that would be the lateral area. Lateral area of a cylinder, 2 pi RH. Then here we only need one base. So we're going to add on just pi r squared. So this is not the total surface area of a cylinder, not the formula we're accustomed to. We adjusted it to just include one of the bases. Okay, when I plug in our values, we have 2 pi times, our radius is still 6. The cylinder has a height of 6 plus pi times 6 squared. And for the cylinder, we would need to cover 339.3 square inches. To find the total area to be covered for the entire solid, we're then going to add together what we got for the cone and the cylinder. So the surface area of this entire solid is about 475.2 square inches. In question number 5, we're going to do exactly the same idea. So this picture is also made up of a cone and a cylinder. Imagine this is a cylinder where they took a conical drill bit and drilled out this cone shape on the left side here. This time I'm going to start with our cylinder. So for the cylinder, again, we need to cover the circular portion, the curved portion. So that would be our lateral area, 2 pi RH. And then we also need to cover the right side of the cylinder, this base here. But we're not covering the left circle because that's left open by the drill. So we have, again, just 1 pi r squared. So we have 2 pi times our radius of 6.2 times the cylinder has a height of 28 plus pi times 6.2 squared. So the cylinder has a area that needs to be covered, 1,211.5. Now when we think about the cone is drilled into the left side of this picture. And for the cone, we're again only going to calculate the lateral area. We're looking at this curved portion of the cone, but the base on the left side is still left open. So for this, we're also going to calculate just the lateral area of the cone. So, excuse me, that's our pi times the radius times the slant height. So our cone has a radius of 6.2 as well, but we're missing the slant height. So if I connect the radius with the normal height of 14, I can use Pythagorean theorem again to find the slant height. So we have 6.2 squared and 14 squared equals our slant height squared. That's 234.44 equals L squared. And when you square root both sides, our slant height is about 15.3. When we plug that into our formula for the cone and plug and chug, we get a lateral area of about 298 meters squared. To find the total area to be covered in this solid, we're then going to add together the two parts that we found. And for this three-dimensional figure, we have a total area of about 1,509.5 square meters. Okay, our last two questions deal with the volume of a cone. The volume, of course, is the space inside of the cone. So if your ice cream melted, would you have enough space in the cone to hold all of it without dripping? If you were filling up one of the conical water cups, how much water could you fit inside, etc. When you look at the volume of a cone, volume is 1/3 area of the base times the height. But because every cone has a circular base, we also think of the formula as 1/3 pi r squared h. 1/3 times the area of a circle times the height of the cone. So make a mental note, this is now the normal height perpendicular to the base, no longer the slant height. When you take a look at question number 6, we're going to find the volume of the cone. So in this picture, we're given the radius of the base, which is 8.6 inches, and we're also given the normal height, 12 inches. So we can simply plug and chug into our formula, 1/3 pi r squared h. So that gives us 1/3 pi times 8.6 squared times 12 for a volume of 929.4 cubic inches, since we're now talking about volume. And in our very last question, when you take a look at the cone here, again, we're going to be calculating volume. So our formula, volume equals 1/3 pi r squared h. In this picture, we have the typical height of 10 inches, but we don't have the radius. Notice, however, that we have a right triangle, and one of the acute angles is marked as 48 degrees. So we're going to have to use our trig functions to solve for the radius. If you're sitting at 48 degrees, the height is the opposite side. Radius that we want is the adjacent side. So that goes with TOA, or tangent. So we create the equation, the tangent of 48 degrees equals opposite, which is 10, over the adjacent side, our radius. So our radius is going to be 10 divided by the tangent of 48. Make sure that your calculator is in degrees and not radians. When you type this into your calculator, you should get a radius of about 9. Now we can plug our information into our volume formula. So we have 1/3 pi times 9 squared times 10. And the volume here is 848.2 inches cubed. As always, please make sure you complete the homework that goes along with this section. Let me know if you have any questions, and have a great day.